testing and comparing 17.5 turn brushless motors to see if they come up to the specifications and which ones are better. I've got about 6 or 7 to test here. Some are the BRCA legal ones and some are not meant for the touring cars. So we've got a Maxilla, got a short stack Maxilla, you've got the Aries or Sky, and the Mutra, and we've got a Team Wave. This is a 17.5, even though it says 17.0 on the end. We've got a Novak Vulcan and the Thunder Power, and I'm going to test them on the motor analyzer. It's important that all the settings are the same to get an accurate reading. So you need a powerful LiPo with a constant voltage output so that it doesn't affect the reading, so big capacity once you do it. And also we're going to have to check and set the timing on the motors all the same. I've done a couple of checks on some of these motors and adjusted them to about near as I can to 45 degrees or 44 degrees. And then I can measure the kV, the amp draw, obviously offload, but it's still an indication, and the revs, and see how they come out. So I'll do them one by one and add them all together. But this is how you do it. Got the Sky Aries one. It's got a figure of 2260 kV. I don't know, they don't tell you what the timing is, but I assume that's a nominal or even voltage they put in. But anyway, on this tester you put, let's just go back to the timing screen. There. Check the timing first, that it's 45, if it's or 44, 45. If it's not, we can adjust the M bell. It just takes a few seconds, and we can do this on every motor one by one, and I'll write down all the results. One interesting motor is the much more Sting, the illegal one with the short stack. See how that comes out. Anyway, as you can see, it's average of 44 degrees. That's what we're looking for is the average, so that's good. And then after you've adjusted the timing, you go back to the kV and turn it up, measure the kV, about 24.6, revs 18,000, current draw about 2.6, it's jumping about 2,2476, and then I can write it down. I measured at 2466 last, 2476 and 18,000, 2.6 amps. So I'll do the others and get all the results written down. Okay, the Maxilla D175, the legal one, 45 degrees, got a nice reading across the sensors. So all we have to do now is check the kV. Nice kV reading, about 2,780, drawing about over 4 amps, about 4.1, and doing 20,000. So and then I'll do the next one. This is the D4 short stack or 1S, 70.5 1S. 44 degrees just tested. Just do the kV rating. Got about 2550, 3.3 amps. So 2550, 3.3, and about 18, jumping around a bit, about 18,350. So I'll write that on there. That's what I read. It's close enough what I did before. So the difference between the normal Maxilla and the short stack one, the short stack one has got less kV, draws less amps, and has less revs. But this is obviously off load, so on load, I'm not sure. Checking the weight of the motors as well while they're out. This is the short stack one, it's 158 grams, and I just measured the normal Maxilla, 157 grams, so there's no difference there. Also I checked the rotors, they're both turquoise in the Maxillas, so I'll weigh the errors as well. The Team Wave Eclipse, setting the M bow to 44-45 degrees is quite hard. It's got a little window in the back, numbered 012, so it's not in degrees, and it comes as 30 degrees as standard, whereas the others all came about 45 degrees as standard. Anyway, we've done the timing. Just do the kV rating. Let's do the kV rating. So about 2590. Drawing 3.2 amps and doing about 18 650, let's call that. Okay, we'll just weigh it in a minute, and I'm going to put the next one in. Novak Vulcan with 12.5mm rotor. The M bow only goes up to 45 degrees. I've turned to max and it's reading 43, and it's the centre board's a bit all over the place. It's got a 40, 44, 46. Anyway, that have to do for the test, so let's go back to the kV. Getting a 2.5, jumping around a bit, so 2.5, revs 18, well 18.1, I've jumped from 18, all over the place, we'll put 18.200, and amps 2.2, very low amp draw. Very noisy too. That's the Vulcan. Weight was 176 grams, so it's quite heavy. So the revs is way down, not quite as low as the Sky. Current very low, very very low. kV 2.5. By the way, this was a mistake. This thunder that was a 13.5 by mistake. So we're going to redo that one. We've got 5 more 17.5 turns here I can test, but they're all in sealed boxes, so you don't really want to unseal them. I've got an X20 17.5, there's the Fleta Sting, you've got the high torque version of the Tekin Red line, they do a rev, oh no, that's a 13.5, so that one's not good. You've got the Orca RX3 17.5 and the Epsima CTM 17.5. They tend to have seals. No, the Orca one seal's gone, so we can do that one. Let's do the Orca one then. Okay, the Orca RX3 17.5, the black version of this motor. Timing, filling with the M bow. The M bow's only got plus and minus figures on it, so we got it close enough. But the sensor board's got some variation, 41 to 45. Anyway, let's we weighed it. It's 169 grams. So So let's just get the KV. We've got 238, current 3.1. We've got RPM 17, about 17,100. So not much, not very good really compared to the others. 238 so far down on the Maxilla. Even the current draw is quite good, but the Revs KV not good. That was a 43 degree, wasn't it? Previous one we did get that right. So I've got another one to do. The GForce Super Extreme, which has replaced their earlier motor. It's now nice and red and everything. M-bell's accurate. Got virtually exactly 45 on the M-bell, and it's come out, got average of 44, which is close enough. Oops, sorry. So let's do the KV. Not jumping, it's good. Even about 257. Amps is low. Revs 18.6. Maybe just below, but I'll put 18. Oh, it's jumping about a bit. And I'll put 18.5. 2.4. Got to now 2. Did go down slightly. Bit of rattling noise. So 2.5. Now, when we tried the Sky, who also made exactly the same as the GForce previous motor, it was 2.46 and 18. KV's gone up a fraction. The Revs a fraction. Not much in it, so. A little bit of extra on the KV, that just might be on the tolerance. I don't know if I've got any others to do. These are sealed, but I'll see if I can find one. The Fleta Sting 17.5. The M-bell got a few, only seems to go up to 40, but we managed to get a reading of 43, though 40 and 46 is not very good sensor board. Haven't weighed it yet, but we'll do the KV. Well, it's doing nice and smooth, about 255, 18,171, 18,000, and the current draw is about 4.9. The voltage has dropped fractionally on the 18,100, say 18,100. The voltage has dropped about 0.1 on the. Well, for the Sting, the current is high, 44 degrees. But the Revs, oh, by the way, the rotor is really, really strong. You can't even turn it when it's by hand without holding the body. So it must be pure bottom end torque, and the rotor's obviously keeping the revs down, because high strength rotor will keep the revs down. So it's all about torque, it looks like, with this motor. Just checking the internal resistance on this very accurate low resistance meter on the Fleta Sting. 0.038, very low. 0.045 is a normal reading, so it must have a very short stack or something. We'll just check another motor, see what that comes out at. The Maxilla 17.5. showing 0.045 is what it should be according to my notes that I made. So the sting was 0.038. So it just shows by checking the internal resistance you can see if the stack is correct. We'll check the stack on the short stack one as well. Okay, the Trinity 1S so-called short stack. It's reading 0.044 and between 0.044 and 0.045. So the wire on it is not really particularly short. So if you measured that and didn't know what the motor was, you would say that was illegal. Not illegal, would be legal. Team Wave, which tested well, actually resistance on the coils 0.048, which is quite poor really, but the higher the resistance, the more losses in the wire, which means more heat. Orca is showing about 0.047, 0.048. On the power, 0.048. The GForce Extreme, quite high resistance, 0.050. It's the highest one we've measured yet. Novak Vulcan, 0.047, just fractionally below. Sky Aries, 0.049. Found an old Orca 17.5, the grey one, which people say were good. Fiddled with the M-bell to get it to read average 44, but it's one of those sensor boards that has way out. That affects performance of the motor a bit, actually, 40, 48 and 44. Anyway, we checked the kV. Now the Orca Black, which we'd measured earlier, it did a 2380 kV, and this is already much higher at 2626. That jumping about is probably the sensor. 2.3 amps, so we just write it down. 2.3, about 266 on the kV, and the revs is 19,000. 2.3, 19,000. 1, 2, 3. So the Orca Black was only 17,000. Grey is 19,000. That was 44 degrees. So and the Orca Black did 2380 kV. This is done 2660. The Black drawing 3.1. This is only drawing 2.3 amps. And I'll measure the resistance and the weight in a second. Okay, the Orca Grey, 0.049 on the resistance, and the black one was 0.047. So the resistance a little bit higher. The weight, the Orca Grey is 158 grams. Black is 169. 10 grams heavier, so it's quite a big difference between the two motors. Finally, just for comparison, this is the Thunder Power 13.5, and showing you how low the resistance is, about 0.030, which means that there's been no confusion if someone had a 13.5 and said it was a 17.5, there's no way. So here's the chart. 0.045, 44, 49, 48, 47, 48, 47, 50, and then the sting at 38. So you really want to aim for one legal that's as low as possible. So the GForce Maxilla It looks like the best motor all round. Certainly the best on resistance, best on kV, best on revs, good current draw. Weight is low too, 157 grams compared to some of these others. Well, honestly, I don't see a better motor on there unless you're going to go that you're allowed to use a Sting, of course.